Okay, talking about the slope of a line. Okay, when I think of slope, okay, what's the first thing that comes to your mind when I say the word slope? What sport?
I guess ski slope.
Okay, I was gonna, a ski slope, okay, that has a vertical down or a horizontal, you know, it's gonna look like this, or it's gonna look like this, okay? So it could also look like this, which is very boring, okay? Or it could look like that. Those are all slopes, if you will. If I have a slope that goes down like this, now I gotta tell you, I grew up water skiing, didn't grow up snow skiing. So the first time that I snow skied, I found this to be a very negative thing. Okay, going straight, I feel like it's out of control. The slope that goes down is a negative slope. Okay, so if I'm reading from left to right, this slope goes downhill. It's negative. If I'm going from left to right, this one is positive. Lots of good exercise going uphill, like if you did cross-country skiing, okay? If you have a horizontal slope, it's a slope of 0, okay? It really brings no emotion to it. You're just there. This one is what we call an empty set. It's undefined. If you think of skateboarding, okay, could you skateboard straight down this wall? You know, could you make that skateboard stick all the way down that wall? No, because the gravity, you'd get about here and then it would just kind of fall down, okay? You can't do straight up and down, okay? It's impossible. It's undefined. You can do horizontal, but somebody who just rides a horizontal skateboard all the time, they're probably not too crazy about it. I mean, we have kids that use the parking lot all the time, but most of the time they're younger kids. By the time you get to be teenagers, you're gonna want the, you know, half pipe, or you're gonna want something that gives some sort of excitement to it, okay? Same thing with slopes on a coordinate plane. So those are the 3 different possibilities I can come up with. So if I take this and I put this on a coordinate plane, and Sam, I'm going to teach it as if you haven't seen it, but I know you have seen it, okay? So just bear with me for a minute.
It's probably better than
Okay. All right, if I want to know what the slope, oops, totally missed, of that line is, I can count. Now I can't count going diagonal, okay? It's kind of like if you play chess, there's certain pieces that they can't go diagonal, they go up and over. I think that's,
I don't know how to play chess.
I don't know what it is either. Okay, so on this one, I can't count diagonal, but I can do that. So what I do is, this is basically a rise, and this is basically a run. So I go, well, I have to go up to where I'm even with that 5. So I go from 4 to 5. That's my y's, right? So I go up 1, and I go over on my x's to 2, from 2 to 6. So that's 4. If I was on like a piece of graph paper, I could just count that. I'm not going to do it that way, but I could do it that way. So the slope here is rise over run. So that is 1 to 4. Now, you can always count that. You can, like, if you have a piece of graph paper and you go, oh, I go up 1 unit and I go over 4 units. You can always get it that way. I don't want to have to do it that way, because that means I have to draw a graph every time. That's very limited. What happens if I have this point? Negative 27 and 140. I don't want to put that on. I don't want to have to draw that. So there has to be another way to find the slope of a line. Now, if you think about surveyors, people that stand out there, you know, with those little tripods, and I'm sure it's done by laser, but they are checking for the topography or the slope of a road or the slope of area. You know, how far up it goes and how far down it goes over a distance. Okay, that's what we're talking about on a coordinate plane. So I've got this going on, I go, there's got to be another way to do it. And there is. There's something called a slope formula. Now, mathematically, all the way through, for a slope, they always use M. I don't know why they use M. I keep always thinking this looks like two mountains, but I'm not sure why they always use M. But when they talk about slope, they're always talking about M. It is the difference in the y's over the difference in the x's. That's sub 2 and sub 1, all it just means is two different x's and two different y's. So let's say I'm going to apply that formula here. I can either choose to have this as my sub 1 and this as my sub 2, or I can do it the other way around. It doesn't matter, okay? It literally does not matter. So if I do it this way, and I'll tell you what I do, I don't even choose what sub 1 and sub 2. I write. I go, I've got the 0.65 and I've got the 0.24. And then I go, typically when you subtract, you go top minus bottom, right? So I go, to find the slope here, I'm going to go 5 minus 4, because I'm going to put the y's on the top. And if I started with that first, I have to start with this one first on the bottom. So 6 minus 2. So that's 1 over 4. That's the same thing I got when I counted. Okay, what if you chose the other way? Okay, if I chose the other way, and I said I'm going to start with 4 on the top. Now understand, these are your y's. They have to go on the top. These are your x's. They have to go on the bottom. So if I go 4 minus 5 on the top, then I have to start with the 2 on the bottom. 2 minus 6, so I have a negative 1 over a negative 4, which is the same thing as 1/4.
So that's, you just did the same thing except you
I did,
you just turned
I
it
just switched, I just made these to be the sub 2s and those to be the sub
So
1s.
it
It
really
doesn't matter, you're gonna get the same answer. What you can't do is this, and this is a common mistake that people make. I can't go, okay, 4 minus 5, so I started with that one on the bottom, and then go 6 minus 2. Okay, I have to keep, if this one I choose to go first, then this one I have to choose to go first. Okay, so that's the one mistake that people can make on those. And the y's have to go on the top. You remember doing this? Okay. Given the case, I'm going to give you a set of points that I want you to find the slope of. Okay? Now, eventually, I'm going to help you program the slope formula into your calculator so that you'll just be able to punch in some buttons and it will regurgitate out your slope. Find the slope between these 2 points on the coordinate plane. Now, obviously, you could graph them, but you can use the slope formula. I'm keeping you awake again, huh?
Sorry. We had like a huge storm at our house last night.
Oh, I know, like 5 o'clock this morning, and it was
It
rough.
was keeping me awake. Because the lighting was so bright and the thunder was so loud, it was like lighting up my room.
It was really intense.
Yeah.
Okay? Anytime you have 0 on the top, the answer's 0. What happens if you have 0 on the bottom?
Then it's just 10. It would be 10.
If you have 0 on the bottom, let's say this was turned the other way around. Okay, this is actually undefined. Okay, this is a horizontal slope, this would be a vertical slope.
Oh.
Okay, now the reason being, think about what this is saying. This is saying 10 divided by 0. What can I multiply by 0 and get 10? Nothing. Okay, so if I have a 0 on the bottom, it is always undefined. If I have a 0 on the top, it's going to equal 0. Okay, always. So if I had graphed this, this would be a horizontal line through y is equal to 5. All right, let's do another one.
Actually, I messed up like the negative sign. I put
Oh, you
0 over negative 10 instead.
gotcha. Do you understand why it's positive 10 though?
Yeah.
And that was a common mistake because it was 7 minus a negative 3, and we have a tendency not to put the negative if there's a minus there, but it's always minus, so it's minus whatever that number is, and that number was a negative 3. So
I
you,
actually wrote it like the other way. I put negative 3 minus 7.
okay, which is negative 10.
Yeah.
Yeah, which is negative. That's fine.
So
Okay.
is that a
So
correct
no, it was
answer?
perfectly fine. So you have that, right? Which is still that.
Still 0.
Okay. So the way you did it was fine. You didn't mess up on that.
Okay.
Okay. Now what they're going to do is they're going to take that stuff. So I don't think there's any problem with that. I think you've got that, the slope stuff. You might have to practice it a little bit. But they're going to ask you to graph some stuff. So they might say, okay, graph the line passing through -2, -5 with a slope of 3/5. So I've got to be able to put that on a graph. So the very first thing that I'm going to do is I'm going to find that point, -2, -5, okay? So there's my point. Then from that point, I apply that slope. So remember, this is rise, and this is run. So this is how far up or down I go. This is how far right or left I go. So from this point, I'm going to go up 3. 1, 2, 3. And then I'm going to go over to the right 5. So 1, 2, 3, 4, 5, right here. And then I've graphed that. Okay? Does that make sense?
I think so.
Okay, I'm going to have you try one. Okay?
Wait,
All right.
the fraction.
The fraction is your slope,
Yes.
is your rise over run.
Mhm.
So this tells you how far up or down you go. If it's negative, go down. If it's positive, go up. This tells you right and left. If it's positive, go right. If it's negative, go left. Okay? If you just have a whole number there, place the whole number over 1. Okay? So if they say you have a slope of 4, then it's 4 over 1. All right, so do this one. Graph, and it doesn't have to be a really exact graph. Graph the line that passes through 4, 5, and has a slope of 3. that what you got?
No,
No.
I don't think so.
Okay.
I was looking.
For one thing, it's not 4.5. Okay, so 4. Oh, here it is. Okay, 4, 5, and you went down. Okay, that's why.
I went over 4.
Okay, but you got to do it from this point. Okay, you did it from 0.
Oh.
You have to, if they give you a point, you have to do it from that point. So from this point, I should have gone up 3 and over to the right 1.
Okay.
Okay, so that's your starting spot right there. Okay? Let's try another one. Okay? All right, try that one. Yes, no, maybe. Okay,
I think
and
so.
and yeah.
I think I know some answer. And
Okay.
it looks a little different.
Yeah. Let's see. -2, 4, and then you went down 1, 2, and over to the right 3. Yeah. Yours is probably way more accurate than mine because mine's just guessing work up there without the grid. Okay. I noticed that it's negative, and remember how we said a negative slope falls, so you can always check it and make sure it's going the right direction. The other thing that they might ask you to do is from an equation, they might ask you to find the slope. So let's say that I have this equation. 2x plus 3y plus 32 equals 0. And I go, what's the slope of this line? Well, what I want to do is I want to put it in y equals mx plus b form, because that right there is going to be my slope. So I'm going to solve for y, is what I'm going to do. So I'm going to take the 2x, well, actually, yeah. I'll take the 2x and the 32 over to the other side. Okay, you with me so far? All I did was I added a -2x and I added a -32.
You just switch the signs. Right.
Yeah, because I took them over. Okay. Now, then I'm going to divide by my 3. So I have y is equal to -2/3 x minus 32 over 3. I don't really even care what that is. Okay. All I'm looking for is the slope. So my slope is -2/3. It's whatever I have right there in front of the x. Because this is in that form. I have y equals mx plus b. So that's the m, that's the b. I'm looking for the m. Okay? Now, the last thing that's in this particular section has to do with parallel and perpendicular lines. Parallel lines, you may or may not remember this. Let's restart this.
You misspelled parallel.
Oh, yep, I am finished.
Oh.
But I did misspell it. Okay, hold on. This thing